Hi everyone, today we are going to go through GCSE AQA Chemistry Predicted Paper 2 for 2024. Please still revise every topic since no one will know what comes up on the day. Also subscribe for more predicted papers and exam questions. We will be doing A-Level soon, and also for next year, we will be going through every type of exam question possible for every topic. Now, the timestamps is in the description for specific topics if you want to go through it if you're combined, and as well as access to the PDF copy. Let's get started. Question 1. Lithium carbonate reacts with dilute hydraulic acid. A group of students investigated the volume of gas produced. This is the method used. Number 1. Place a known mass of lithium carbonate in a conical flask. Number 2. Measure 10 cm cube of dilute hydrochloric acid using a measuring cylinder. Number 3. Pour the acid in a conical flask. And number 4. Place a bung in the flask and collect the gas shown in Figure 1. Figure 2 shows a measuring cylinder. What volume of gas has been collected? So we can see over here that this area is the water. It's wherever the liquid is that they were using. And over here is the gas that's actually been produced. So we need to just measure this. It is a bit difficult now that it is upside down, but all we have to do is read this over here. You can see that we are going up this way. So this should be 35, and which means this should be 36, and the answer is 36. B. The table shows the student's result, mass on one side and volume on the other. On Figure 3, plot the results on the grid and complete the graph by drawing two straight lines of best fit. They already gave us what our y and x axes is, so all we have to do is put them together. So 0 and 0, that's already done for us. So what we do is just 0, 1, this on our x axes and this is on our y, and each one is matched together. So this is how the graph is going to look like after we plot all our points. So we can already see by the clue that they gave us that we need to draw two lines of best fit. Our first one is going to be this line over here. This is because all the three last digits is all 96. So that is our first line because it starts to plateau at this point. Our second line of best fit, we want to go through as many points as possible, and we go through our 0, 0 point. If we go through, we can see that we go through these three over here. If we just draw a line like that, and we just connect these two together, this should be our line over here. And don't worry if you see there's an anomalous result, this is completely normal, and especially since in the next question we know we talk about it, so this is completely fine, but that is our two lines of best fit. C. What are two possible reasons for this anomalous result? The first one is the bung was not pushed firmly enough. This is because the gas was able to leak, so we didn't actually get the accurate measure of the gas, which means that the volume of gas was much less than what it was supposed to be. And our second one was that the measuring cylinder was not completely over the delivery. This again means that we have lost volume. That's why our volume is much less than the other one. We want to see reasons why it's less, not more. D. Describe the pattern of the graph shows up to 0.4 of lithium carbonate added. 0.4 is over here, so we can see that it just goes up into a straight line. It is a positive correlation. So what we can say is as the mass of lithium carbonate increases, we know that the volume of gas also increases, so it is a direct proportion. It is completely linear. E. Lithium carbonate decomposes when heated. The equation for the decomposition of lithium carbonate is shown below. Figure 4 shows the apparatus of a student used to decompose this lithium carbonate. We have lithium carbonate over here, and we have lime water and a Bunsen burner heating this lithium carbonate so that we can decompose it. What does a lime water bubble mean? It just means that a gas is produced, and this gas is a carbon dioxide. So if you see bubbles when we do the lime water test, this is the test for carbon dioxide. The students repeated the experiment with potassium carbonate. The lime water did not bubble. Suggest why there was no bubbles in the lime water. And this is because potassium carbonate does not decompose to produce CO2. It does not decompose at the temperature of the Bunsen burner since it's not hot enough to actually decompose our potassium carbonate. So when it does decompose, this gas is not formed. 2. The rate of reaction between a magnesium ribbon and a dilute hydrochloric acid at room temperature is investigated. The apparatus used is shown in Figure 11. The volume of hydrogen gas is given off is measured at regular intervals during this reaction. We have magnesium ribbon over here, and this is in a conical flask. We have this over here that goes into a upside down measuring cylinder, and this is so that we can measure the gas that is producing over here. The graph in figure 12 shows the results of this experiment. Suggest a change that could be made to the apparatus in figure 11 to measure the volume of gas more accurately. Here, instead of a measuring cylinder, what we could use is a gas syringe since it's more accurate. We could also use a graduated tube or even a burette. This is, let's say, for a measuring cylinder, it goes up in 1. However, for a syringe, a tube, or a burette, it will actually go into even smaller. So we say millimeters or even less, which means it's more accurate. We can get our result at a much more accurate rate since we get it to the nearest millimeter or even smaller than that. It's as accurate as we can possibly be. A tangent has been drawn to the line on the graph in figure 12. Calculate the rate of reaction at this point. Here is our tangent. To find rate of reaction, what we do is that we calculate what our gradient is of this line. We do what's y over x. So all we have to do first is draw a triangle in where this tangent is, and we just need to see what this value is and what this value is over here. So over here we can say it's around 15, and this goes up to 44. So all we do is 44 and minus that from 15, and we would get 29 as our y coordinate. Now if we go up here, it just goes up to 60, so our x is 60. In other words, this y over x is the exact same as amount over time, which is how we find the rate of reaction for anything if they just give you values. So if we just do 29 and we divide this by 60, we would get our rate of reaction to be 0.483 recurrent. Now this will be different whether you're doing it on paper because we're doing this electronically. On the graph in figure 12, draw the line you would expect to obtain if the magnesium ribbon in this experiment was replaced with an equal mass of powdered magnesium. All the other conditions are kept the same. The key word over here is powdered magnesium. If it is powdered, this means we are increasing the surface area. Increasing the surface area means that we're increasing rate of reaction. It decreases the time taken for the reaction to happen. This means that this experiment will happen even faster, so we just become, it's a more steeper curve, and it actually starts to plateau. You see this line over here where it stops. It starts to plateau at a much earlier rate, and it's a much steeper reaction, as we can see over here. We can see here that the volume of hydrogen increases much faster at a smaller amount of time. Make sure that it always ends with the same volume because we are not messing with it. They told us that it was the equal mass. If they said it was half, then it would be half a volume. If they said it was doubled, it would be double volume. Here they say equal, so our volume of hydrogen produced will be the exact same. Question 3. Qualitative tests are carried out on an ionic substance to identify the ions present in that substance. The test for a given ion must be unique to that ion. Explain why the test for a given ion must be unique to that ion. This is basically logic. It's because the test should be only to detect that exact ion, so there's no other confusion with other ions. So let's say, for example, if there was the same result is given for more than one ion, let's say both of them will turn purple for both the ions we're testing, we wouldn't actually know which ion is present, so it makes it all confusing and we aren't actually accurately trying to identify the ion that we are given. In the test for a carbonate ion, dilute hydrochloric acid is added to the solid being tested. State the name of the gas produced if carbonate ions are present. Now, because they add dilute hydrochloric acid and this is to a carbonate ions, this is going to be carbon dioxide. Tests for 3 ions are described. Draw one straight line from the test of each ion to the observation that shows the ion to be present. Each observation must be correct for one test, more than one test, or none of this test. Now we have the test for chloride ions. We add dilute nitric acid followed by silver nitrate solution. We get a white precipitate. The test for iodide ion, it's to add nitric acid and followed by silver nitrate solution, and we get a yellow precipitate. Now we test for sulfate ions. We add dilute hydrochloric acid. We followed by barium chloride solution. We will get a white precipitate. Now don't be scared if we have multiple ones that are none or multiple ones that have 2. They said in the question that this will be okay. And also precipitate just means a solid that is left, kind of like a powdered solid that's left at the end of the experiment, at the end of the test. Question 4. Qualitative tests are used to identify ions in the compound. Instrumental methods are often used for this analysis. Give a reason why instrumental analysis may be better than other methods of analysis. This is simply because it improves the sensitivity of it, which means that it's going to be much more accurate, and it also allows it to happen faster. The test will be speedy. Question 5. The alkanes are a homologous series of hydrocarbons and it's obtained from fractions in crude oil. Describe how crude oil is separated into fractions in industry. Now this diagram over here is to show how a fractional distillation works, because this is what we use. We use a fractioning column or a fractioning towel. So the first thing we do is that the crude oil is put into a furnace and this is heated, and then it goes past and goes into this fractional column. Once it goes into the fractional column, it has varying temperatures so that every single part there is different sections that separate each one, and each section has a different boiling point, and it has it so that it's really hot at the bottom and it gets colder as you go up, so that gas is released because it has the most lowest boiling point temperature. And this is because it works on a temperature gradient. So our crude oil has different oils within it, and all of those have a different boiling point. And because they all have different boiling points, they are going to settle into whatever section of the boiling point is in that section. So let's say over here has around 400 CCS. Whatever oil inside that crude oil that has 400 CCS will stay within this limit. It will not go any higher. And whatever has a really low boiling point will go higher to the top. State the general formula of alkane. This is CnH2n plus 2. State two characteristics other than having the same general formula of members of a homologous series. Now there's lots of different properties and features of homologous members of a homologous series, and these are that they have similar chemical properties and reactions. They also have gradual change within their physical properties. Now this can either be increase or decrease. An example of this is their boiling point, and also they have a same functional group, as well as that their neighboring members are always going to differ by a CH2. Ethane C2H6 is present in crude oil. Write a balanced equation for the complete combustion of ethane. So first of all, we have ethane is our beginning, so we know that that is C2 and H6. We just use it based on our formula over here, and eth means 2 carbon. And then because it's a complete combustion, we put it with O2. This is oxygen, and this always, a complete combustion always puts out 2 products, and this is CO2 as well as H2O. Now all we have to do is balance it. Now that there is 14 oxygen over here, this will be 7. 6. This question is about reversible reactions and equilibrium. Hydrogen is used to produce ammonia, and this is in the Haber process. Hydrogen is made in 2 stages. Step 1, the reaction of methane and steam to produce carbon monoxide and hydrogen, and the equation for the reaction is over here. A. Calculate the atom economy for the formation of hydrogen in stage 1. They want the atom economy for hydrogen, so it is over here since it's the formation, so it's hydrogen the product. We can see that we have 1 is the atomic mass, so there's already 2, so that's going to equal 2. However, we have this 3. We have this 3 over here we have this 3 just before hydrogen, so we do also need to times it by 3. So overall, it is 6. The atom mass of hydrogen is 6. Now we have to divide it by the atomic masses of all of the reactants added up together. We have our C, so that's 12. Plus 4 hydrogens, so 1 times 4, that's 4. We add this with 2 hydrogens, so 2. And we add this with an oxygen, which is 16, so plus 16. All of this will equal 34. So we divide by 34, and atomic economy, we can see over here as a hint, it is a percentage. So we times it by 100, and our answer would be 17.6%. B. Explain why a low pressure is used in stage 1 and give your answers in terms of equilibrium. So over here we can see that this is an equilibrium. This just means that it is a dynamic equilibrium, so it is a reversible reaction, this sign over here. The first thing we do so that we can figure out is calculate how many moles there is in each side of the equation. This is just by calculating the big number that comes between each of our compounds. So we have over here, we don't have anything, so that's actually just an invisible 1. So this is 2. Here we have 1 again since there's nothing, but here we have 3. So over here it's actually 4. Now, why is a low pressure used in this temperature? Because a low pressure is always going to go into wherever the highest mole is, because with Chatelier principle, we always want to reverse the action that has just been made. So if we reduce the low pressure, our reaction is going to want to increase the pressure again so that it goes back to normal, and the way to increase pressure is to increase our moles. So it's going to favor the forward reaction since it has more moles. So we just explained this by either saying, because we get a higher yield, this is what we are after, so we get a higher yield, and this is because fewer moles are on the left hand side, or we could say because there are more moles on the right hand side. In these ones, we always give the reason why, and why exactly did it favor one side over the other. C. Stage 2 uses carbon monoxide produced in stage 1. Carbon monoxide is reacted with more steam to produce carbon dioxide and hydrogen. The equation of the reaction in stage 2 is that what is the effect of increasing the pressure on the equilibrium yield in hydrogen in stage 2? We do the exact same thing. All we do is see how many moles are in each one. So we have 1 in each single one. So we have 2 reactants over here and we have 2 products. So the moles are actually the exact same. And because there is no one mole has more than the other, it will have no effect at all on the yield. Now let's say if we did have, for example, another element here such as oxygen, though it does not work, this will actually turn to be 3 moles. So it will favor the left-handed equation, it will get less yield. So just make sure that you count it correctly, and just because there is no numbers before it doesn't mean there's nothing, it is counted as 1. The graph below shows the percentage yield of ammonia produced at different temperatures and pressures in this Haber process. At temperatures 450 and a pressure of 200 atmospheres are used at the Haber process. A student suggested that the temperature of 350 and a pressure of 285 atmosphere could be used instead in this Haber process. Determine how many times greater the percentage yield of ammonia would be using this graph. First of all, we're going to see 450 and 200. We have 450 over here. Now all we have to do is see where 200 is in the atmosphere, and it is this over here. As soon as we hit the curve of our desired temperature, which is 450, we are going to start going to the other side, so we make contact with the y-axis. We can see over here it is around 28%. Now what we're going to do is we're going to use 350 and 285. So we have 285, which will be around here. And we keep going up until we reach 350, which is over here, and we go to the side, and this is going to be around 63%. We can already see that what the students suggested will get a much higher yield. It would get 63 yield, but they are not asking that. They are asking how many times greater the percentage yield is. Because they're asking how many times greater, we know that this is a division type of calculation. So all we have to do is we have to do 63 and we divide this by 28, and once you get your answer, you would get that it is 2.25 times greater. A pressure of 285 atmosphere is not used in the Haber process instead of 200 atmosphere. Give a reason why. There's multiple reasons, and this is that the energy cost will be higher. Never say it will be expensive. You have to justify why it's expensive. So in this case, it is the energy cost. We also say that the equipment that we would need will be much more stronger. It's also more expensive, and it's to maintain and to build it in the beginning. And also higher pressures can be much more dangerous for the people that are working around it, and this is because there is a risk of explosion. F. How does graph above shows that the forward reaction in the Haber process is exothermic? This is because if you see over here at 450, which is a higher temperature, which usually means that the rate of reaction will increase and that we get more yield, is actually going to give us 28, while if we use less, we actually get much more yield. So this shows that our forward reaction is exothermic. This is because if a forward reaction is exothermic, increasing the temperature is going to make it favor the endothermic reaction, which in this case will be the left-handed side, so the yield will be lower. Instead, if it was endothermic, higher temperature would go to the other way, if that makes sense. G. World production of ammonia is now 30 times greater than it was in 1950. So just why the demand of ammonia has increased. This is because world population has increased. Because world population has increased, there is more humans, and us as humans, we need all these resources so that we can continue living the life as we know it. And this is because the demand of fertilizers has increased because more food is needed. We also want increase in demand for, let's say, drugs, dyes, explosive, even nitric acid. All of these are needed for our human life. Draw one line from each gas to the source of that gas. Hydrogen source is from natural gases, and nitrogen is found in the air, just our normal atmospheric air. 8. Some fractions containing long-chain hydrocarbons are cracked. The cracking of octadecane produces octane and one other product. Write the chemical equation for this cracking reaction. So it already told us that it is octadecane, so we do C18H38, and cracking just means that we equal it. This is to C8H18. Now all we have to do is just find out what's missing. We do our carbon, how many carbon has been gone. So we do 18 minus 8, put our carbon here, it is 10. So we just do it like that. We do H, now we see we do 38 minus 18, and this is 20. We just see whatever is missing and we put that into a new compound because elements can't just be destroyed or recreated. It always just needs to be put into a different thing. Explain why it's important to crack long-chain hydrocarbon fractions. This is because we always have a greater supply of long-chain hydrocarbons and this heavier fraction. However, we have a much higher demand and more use for the short-chain and small hydrocarbons. This is because the alkenes that we get from it can make polymers or plastics, and also short-chain hydrocarbons can also be used as fuels. So we much prefer it. That's why cracking is beneficial for us. Question 9. This question is about gases. Figure 16 shows relative amounts of 3 gases in early atmosphere compared to the composition of today's atmosphere. Natural processes and human activities have altered this relative amount of these gases in the atmosphere. Explain how this relative amount of each gases has increased or decreased over time. So if you see water vapors, this is large amount. However, now it's 0 to 4%. We can say that this has decreased. We have carbon dioxide, this is a large amount, and now it's less than 0.5, therefore as decreased. And oxygen is little to none, and now we have 21%, so that actually has increased. So first of all, we can talk about our origins. For example, we are going to talk about how it is found in early atmosphere. We can say that carbon dioxide, water, gas, these has originally came from volcanoes. However, as time passed, the earth has cooled. This means that water vapor has condensed, and this reduces the amount of water vapor as shown over here. Also, carbon dioxide is now dissolved and absorbed by the ocean, which means that it reduced the amount of carbon dioxide, and carbon dioxide is actually incorporated within the sea animal shells, and this is why both of them has decreased over time compared to relative amount of early atmosphere. Now we can talk about evolution, and this is because that when plants evolved, we get more photosynthesis. Photosynthesis releases oxygen, which means that it increased oxygen, which is why there's so much more, since we can say that there's so much more plants now, and this is because of evolution, because of more photosynthesis. And also it does contribute to why carbon dioxide is now much less, because with photosynthesis it reduces the amount of carbon dioxide since they take in carbon dioxide and they release oxygen. Now that we have went through natural processes, what they want is human activities. With human activities, we can say that the amount of carbon dioxide in recent times, however, has been increased. This is due to burning fossil fuels, and amount of carbon dioxide in recent time also increases due to agriculture. However, deforestation does mean that less carbon dioxide is absorbed, and also reforestation, which is a very recent thing where we start to plant more, means that more oxygen is going to be produced. And this is why. Think of a logical way on why these things has happened and link it to the syllabus. They'll never give you a question that you do not have the knowledge for, so just apply it to whatever you have already learned. And make sure that you always go through every single thing that they gave. Lots of people just focused on today's atmosphere, talking about climate change and global warming and increased carbon dioxide, but that's not what the tables show us. So it's not something we should focus on. Instead, lots of people did the mistake where they did not talk about the relative amounts in early atmosphere. Why were they like that? As well as not talking about our natural processes, only focusing on human activity when the question clearly states. So make sure you address every single part of the data that they give you, as well as every part of the question they ask for. Question 10. Polymer molecules can be made by joining together large number of smaller molecules called monomers. Figure 5 shows the name and structure of some polymers and the monomers used to make them. Complete the table using the information that is given. Now we have polyethane, and they want us to draw the structure of the polymer molecule, and we have our monomer over here. The first thing we are going to do is break this double bond. So it'll be C to C, just one single bond that's saturated, and then we are going to add our hydrogens in. This double bond, it just goes to the side over here, and let's say there was another one on the side that did the same, it will give that their double bond. And what we do to just complete our structure is to put our brackets in. This just shows that it's repeated again and again and again. Since it's such a large molecule, polymers are such large molecules that we can't draw every single one since it's a waste of time. So instead we just put N, and N is just the number of times it's repeated. It could be different for every time. Now for polychloroethane, we do the exact opposite that we just did. First thing we are going to do is just put out all the elements. So we have C, C, H, Cl, H, and another H. We remove our double bonds that we have on the side, and instead we put our double back over here, and we do not need to include the N or the brackets. Now for the last one, they gave us the structure of the polymer molecule as well as our monomer. We need to name the polymer from naming our monomer. Now they already gave us a hint. You can see over here we just add poly and in brackets whatever the name of the monomer is. So it would just be poly, and we put tetrafluoroethane in brackets. Question 11. Hydrogen is needed for the manufacture of ammonia, and it's a process called steam reforming. In this process, a mixture of methane and steam is passed over a nickel catalyst. The equation for this reaction is that, in this part of the question, assume that the reaction reaches a point of equilibrium. Predict whether a high or low temperature would produce the highest yield of hydrogen and give a reason for your answer. So they say over here that the forward reaction is a endothermic reaction because it's a positive. This means they want to see if a high or low temperature. For it to favor an endothermic reaction, it needs to be a high temperature. This is because it's always the opposite. So we need a high temp, and this is because we always say our reason as in forward reaction. Forward reaction is going this way, the way that we're normally used to seeing, and backward reaction is this other way. Forward reaction is endothermic. Predict whether a high or low pressure would produce the highest yield of hydrogen. With pressure, all we do is calculate the moles for each one. Over here we have 1 and 1, so we add all the reactant moles together. 2, we have 1 and 3, add all the product moles together. This is 4. We have more moles on this side than the other side. So if we want something to favor more moles, we need to lower the temperature. Again, it's the opposite. So it's low pressure, and we can say right hand side, we can just abbreviate, say has more moles. Now explain how a catalyst increases the rate of reaction. This is because it provides an alternative route with a lower activation energy. So let's say we have our activation energy diagram over here. It goes something like this. Now this energy is really high. It takes a lot of energy and lots of temperature and heat so that we can go up over here. A catalyst instead gives it a different route so that it can go up from here. This is a much lower energy that is needed, so more reactants are able to reach that energy so products can happen. So this means our rate of reaction will be much faster, and the time taken for that reaction to happen will decrease. And this is because it is in a catalyst. We just say that gas molecules will actually stick to the surface of the catalyst, and what they do is just weaken the molecule bonds, the covalent bonds between these molecules. Question 12. The name, structures, and boiling point of ethanol and 2 other alcohols are shown in Table 3. Use the knowledge of structure and bonding to suggest why boiling point increases as the number of carbon atom increases. You can see we have 1 carbon, 2 carbon, and 3 carbon over here, and our boiling point increases with time. Now this is pretty simple. What we say is because the molecules get bigger, and this means that the number of carbon basically increases, the intermolecular forces also increases. This is because we're going to have more bonds. So over here we only have 5. Now over here we are going to have much more. We have 8. And over here we are going to have 11. Every single one of these bonds have to be broken so that it can reach the boiling points where it becomes a gas. Every one of these points have to be broken. So the fact that there is more bonds means there's more energy, more bonds that is needed to break. So how we say this is that we say that the intermolecular forces are going to increase. And therefore, always the last thing that we add so that we can get that last 1 point every time we're talking about bonding and structure and atomic structure is that it requires more energy, which means more heat, to overcome and to actually break these bonds. Question 13, Figure 1 shows a toothbrush in a container. The toothbrush handles are made out of plastic. Give a reason why plastic is a suitable material to make this toothbrush handle. Now there is different features of plastic which makes it very useful. This is that it's strong, unreactive, it can't react with, let's say, water, air. It's also non-toxic and it can be molded to whatever shape you want. So over here we can just say be basic and say that it is very strong so it will not break easily. Some toothbrush handles are made out of wood and not plastic. Explain a disadvantage of using plastic. Now we can go in the sustainable route. So we can say plastics are made from crude oil and this is not sustainable. It uses a finite resource which is not good for the environment. Also, plastic is non-biodegradable and it will end up in a landfill. This contributes to all the problems we're having right now. Question 14. Ethanol is produced by fermentation of glucose and yeast is needed for this fermentation reaction. State 2 other conditions for fermentation. They actually have a lot. First of all, we need to dissolve the sugar. It has to be an aqueous solution. Also, it has to be warm around 25 to 40 Celsius. There also needs to be absence of air, no oxygen. It has to be anaerobic respiration only. The pH also has to be neutral, slightly acidic from 4 to 7, and has to be a sterile condition. Complete the sentence by putting a cross in the box next to your answer. A dilute solution of ethanol can be converted to a concentrated solution of ethanol, and this is by fractional distillation. Write a balanced equation for the fermentation of glucose. First of all, we have our glucose over here, so we just copy it down. And what this happens is because it's fermentation, this is going to create ethanol. We just put out what we know ethanol looks like this. And our byproduct is going to be carbon dioxide. Now, all we do to balance it is that we see over here we have 6 carbons. We need to have 6 carbons on the other side. So we just put 2 over here and we put 2 over here. So now we have 4 and 6. The table shows 2 different processes for making ethanol on a large scale. We have the batch process, and this is the fermentation of sugar with yeast, which is what we just went through. We also have the continuous process, which is the hydration of ethane, and this is produced from crude oil with steam. Compare 2 processes in terms of the rate at which ethanol can be produced, the purity of the product, and the use of finite resources. So we just go through every single one since only 3 marks. Now we are going to focus on the batch process. We can say the rate is much slower than the continuous process. Continuous process is much faster. It's also less pure. The continuous process is going to be much purer. And then with use of finite resources, we can say that use of renewable resources during the batch process, it's much more sustainable, while as the continuous process does only use finite resources. C. The equation for fermentation of glucose is that a mass of 3,600 kg of glucose was completely fermented. Calculate the amount in moles of the glucose that was fermented. The equation that we are going to use right now is that moles is the same as grams over mR. So over here we can see that it's kg. We need to always convert any mass that we have to grams. That is the standard unit to use for all calculations. You will get it wrong if you don't do that. So to convert kg to grams, we just times by 1,000. So it's 36 times 1,000, and we just divided by our MR, which is 180, and if we just put that into our calculator, we get 20,000 moles. Deduce the amount of moles in the ethanol is produced in this reaction. Here we look at the ratio. We have the ratio 1, and the ratio is given by that big number before our actual product, and this is 2, so it's 1 to 2, so our mole ratio is the same. If 1 is glucose is 20,000, then we have double for whatever ethanol is, so we just times it by 2, so it will be 40,000. Calculate the volume in carbon dioxide produced in this reaction, and they want it in dm cubed. The equation we are going to use is we're going to use moles and times by 24, and this is going to get our volume. So we have our moles over here we want of carbon dioxide. If you look at the ratio, this is also to 2, so it will be the same as ethanol. It will be 40,000 times this by 24, and 24 is in dm cubed. All gases, like how we have all masses in grams, all gases are going to be in dm cubed. So we don't need to do any conversion, so we just do that into our calculator and we get 960,000. 15. Ethanol C2H5OH can be converted to ethanoic acid. In this reaction, ethanol is completely oxidized. Draw the structure of a molecule of ethanoic acid and show all the covalent bonds. All the covalent bonds, in this case, they just want us to, this is how our bonds look like, it is just lines. So first we are going to put our 2 carbons that we have here. So we have our 2 carbons and this is connected by a line. This shows our covalent bonds. Now we can see that this carbon over here is connected to 3 hydrogens. So we can just put this over here. And we can see that this carbon is connected to another carbon as well as 2 O's and an H. So we have O, O, and an H. However, carbon has 4 electrons free, so it needs to actually have 4 different bonds. Right now it only has 3, and we already know that this is ethanoic acid, and our functional group is going to be double bond O with an OH group. So we just put our extra bond over there. Question 16. Petrol and diesel are used as fuels for cars. The emission for the 3 similar sized cars were investigated. The first car was the oldest and had no catalytic converter and used petrol. The other 2 cars were only a few years old. One of these was fitted with a catalytic converter and used petrol, and the other car used diesel. Figure 9 shows the emission in grams for each kilometer traveled by these 3 cars. Discuss and compare the impact on the environment of these emissions of the 3 cars and use the information from figure 9. Now if you see here, the car with no catalytic converter using petrol is much more in carbon monoxide. However, it's middle with the nitrogen oxide, and carbon dioxide is the same as these 2, and no carbon particulates. Now, car with catalytic converter and using petrol has a middle carbon monoxide. It has the least nitrogen oxide and the same carbon dioxide and no carbon particles. And we have car using diesel. We have the least carbon monoxide and we have the most nitrogen oxide, but least carbon dioxide and most carbon particles. Now they want this impact on the environment. So what we can say, the first thing we can do is see what each type of these emissions are actually harmful and how by the environment. And we can first say that the car with no catalytic converter has the most carbon monoxide, and carbon monoxide combines hemoglobin with hemoglobin, so it's very toxic since it stops you from breathing completely, like 100%. We can say that with nitrogen oxide, the car using diesel actually has the most. Nitrogen oxide is very acidic and toxic, and it does lead to acid rain. Acid rain is really bad because it damages our building and kills our plants. Now we have carbon dioxide. It's actually the exact same for the car with no catalytic and the same with the car with catalytic, and the least for diesel. We can say that carbon dioxide is bad. This is because it's a greenhouse gas, and this causes global warming such as sea level risings. And then at the end, we can say that the car with diesel has the most carbon particulates, and this is really bad because it does sometimes causes breathing difficulty and also makes a lot of the buildings look very dirty. Now we're going to go into more detail. We are first going to pair petrol and diesel. What is the difference between the two? Compared to diesel, petrol will release less nitrogen oxide and release less particulate particulates, which is very good. However, it will release more carbon monoxide and more carbon dioxide. And with catalytic converter, now if you look at what the effect is between both of them, it does reduce carbon monoxide as well as reducing nitrogen oxide. So we can say that catalytic converter is a good thing. Now, our overall comparison is that petrol car improved with catalytic converter as two pollutants is reduced. Diesel is also better than petrol for carbon oxide, but diesel is worse for particulates and nitrogen oxide. And this is just an overall of what things you can write. You don't need to write everything. It is only a 6-mark question, but make sure when you go over it, you go over every single thing that the table tells you, go to every single detail, and make sure you answer the question. It says discuss, as well as compare the different ones, and make sure that you use the information in figures, so they do want data into your answer. Question 17, explain how different dyes in X are separated by paper chromatography. Now, paper chromatography kind of looks like this. It's where you get a paper and with a pencil line, you draw your different dyes into it and you plot them in. You then put it onto a solute, maybe something like ethanol, and then it goes up into different ones. So let's say this will end up over here, this ends up over here. This could end up with 3 different things because it separates the pigment. Now, they're just asking exactly how does this happen? So what happens is that our solvent is going to move through the paper, and our different dyes have this different solubilities to the solvent, how soluble it is within it. That is going to affect how far it travels. Also, they're going to have different attractions to the paper. That is why it's all carried to different distances. Flame emission spectroscopy can be used to analyze metal ions in a solution. Figure 3 gives a flame emission spectra of 5 metal ions and a mixture of 2 metal ions. We have our metal ions over here and the mixture. Use the spectra to identify 2 metal ions in this mixture. Now all we have to do is look for our similar ones in this line. So you can see over here is a pretty obvious one, since this closely matches to Ca2 to our calcium, since it's the only one that has a lot over here. So our first one will be calcium 2 plus. Now, if we look at our other ones, we need to go ahead and just cancel all of these that are the exact same as calcium, since we don't want that to be involved. Now, what we can see these two don't correspond. We can see this over here most likely corresponds. This is because over here we can see that there is more lines, since over here is more lines than this area over here. And also there's this one over here that isn't over here. Now, this could be this as well, but it doesn't have this other line, so it has to be sodium. Explain why a flame test could not use to identify the 2 metal ions in the mixture. This is because these two are 2 completely different colors, so the colors will mix, so we won't be able to see another, since one color might mask the other, so we won't be able to identify which ions that is. 2 students tested a green compound X, and the student added water to compound X, and compound X did not dissolve. The students then added a solution of ethanoic acid to compound X, and a gas produced which turned lime water milky. Student A concluded that compound X was sodium carbonate, and student B concluded X was copper chloride. Which student, if any, was correct? Now, they said that it was sodium carbonate and that compound X did not dissolve. However, this is going to be incorrect because sodium would have dissolved, so this means it cannot be sodium carbonate since it's soluble because of those sodium ions. Now, it can be copper chloride either way, because it says over here that there was a gas which turned lime water milky. We know that the test for lime water, and if it turns milky, is CO2. So it cannot be chloride, instead it is carbonate. So they were half correct. It is not chloride ions, instead it is carbonate. Thank you so much. That is the end of our predicted paper. Please let me know if you have any questions, whether it's to do with the predicted paper or its content just in general. I'll be more than happy to help. I hope the exam goes well. Good luck with studying.